This is the first part of the magnetic field lab, and first part is just to map the magnetic field, produced by the current in this loop. So you have this loop, something like this. So this is the loop, coil, having some 200 turns, right? And when you connect it to the power supply, then it produces magnetic field, right? And then using this paper and cardboard, you can map, the magnetic field around it using this compass needle. So that's the compass needle, and so I'm supplying about 1.2 amps of current. So 1.2 amps of current is flowing through this loop, and then it has magnetic field. And to prove this, immediately you can see the magnetic field. So if I put the needle, right, compass needle at the center, if I turn the field off, let's see what will happen. So it will just point towards the north and south, right? But when I turn the field on, when I turn the current on, it immediately aligns in the direction of the magnetic field. So that simply means the magnetic field at the center of this loop is in this way. So now we're gonna, using a pen or pencil, we're gonna just map the magnetic field around this, so just point, you can start from anywhere, so something like that, and then again put hair and tail like this and like this, and this, right? And then you can do a couple more, so something like this. And after joining all the points shown by the this compass needle, this is how the magnetic field pattern, around the loop look like, right? As I just, and look at the direction. The arrow should point towards the, the north pole. This is the north pole of the compass, right? That should be the direction of the magnetic field produced by the loop. So this is the setup for our last part of the experiment, second part of the experiment, where we will measure the magnetic field due to this loop, right, at different current, and using that data, magnetic field versus current, we will do some analysis, and then we will find out the permeability constant mu naught, the universal constant. So here's the setup. So you have this loop, right, and it's connected to the power supply in current mode. So I'm gonna change the current from 0 to 1.4 amps, and I'm gonna measure the magnetic field at the center of the loop. And this is the magnetic field sensor. This is the magnetic field sensor, right? And this is interface with the computer through this digitizer, right? And then using the Logger Pro software, I'm gonna measure the magnetic field at various currents. So starting from 0, so at 0, right, at 0 amp, you expect 0 magnetic field, or very little magnetic field, right? So let's start with, and one more thing, so you have to measure some dimensions of this coil. So the diameter of this coil, from center of the coil to the center of the coil, I have already measured it. The diameter of the coil is 20.5 centimeter, and the length, it says, the manual says the length of the coil, which is nothing, it's just this thickness, is 1.6 centimeter, okay? And the number of turns, it has 200 number of coils, 200 number of turns. That's your big N. So starting with 0.2, so I'm going to put 0.2, and make sure you record all these values. So starting with 0.2, it doesn't need to be exactly 0.2, but try. So okay, 0.2 what's the magnetic field? So we have to hit this button, collect, right, around for 5-10 seconds. So it's collecting the data, and then we take the average. So the average, how do you take? So we're going to use this very useful tool called statistics. So it will automatically do statistics and find the mean value. So the mean magnetic field, right, is, write that down, is 0.24 millitesla. These are all in millitesla, okay? All these measurements of the magnetic field are in millitesla. Okay, now just we will leave this statistics tool here and it will automatically measure everything. Now go to 0.4 and you have fine tuner here and measure the magnetic field, and we expect the magnetic field to increase, right, as we can see in the data. And then here's the average. The magnetic field, right, at 0.4 amps is 0.51 millitesla, and 0.6 at 0.6, it doesn't need to be exactly 6. At 0.6, let's hit that. So here's the data, and at 0.6 the magnetic field is 0.775 millitesla. Let's go to higher, 0.8. At 0.8, so magnetic field is increasing constantly, right, as expected. So at 0.8 amp of current, the magnetic field, the average magnetic field is 1.048 millitesla. Okay. Now at 1, at 1 amp, let's see. Okay, so at 1 amp of current, the magnetic field is 1.32 millitesla. At 1.2, so it's at 1.2, right? What's the magnetic field? Let's see. I'm just gonna take average. So at 1.2 amp, the magnetic field is 1.583 millitesla. Let's do the last one. Okay, at 1.4 amp, so the average magnetic field is 1.863 millitesla at 1.4 amp.